Earlier, we worked with using Pythagorean Theorem to solve some other concepts, such as maybe a perimeter or something like that. So today, or this time, what we're going to do is we're going to go through and check, when given dimensions, if those dimensions would actually create a right triangle. So remember, Pythagorean Theorem is actually only used if you have a right triangle. So in order for it to work, we have to have a right triangle. So this is called a Pythagorean triple, and that's when you have a set of three positive numbers, so A, B, and C, where they fit into Pythagorean theorem and are equal to each other. So the way that we check this is we go through and we fill in our information, and then we check, are they really equal to each other? So our right, where it looks like our right angle is, or right triangle, right angle of our triangle would be right here. So those are my A and my B, which means my longest side is my C, or my hypotenuse. So I'm going to go ahead and plug that information into this equation, just like I would do any other time. It's just that they've given us all three. So we just have to check to see, do the AB side, does that equal the C side? Okay, so 36 squared, and then I write 3. 36 squared plus B squared is 27 squared, and that equals C squared, which they're telling us C is 45. Okay, so what we're going to do is we're going to go through and actually simplify this all out and see if those two sides equal each other. So when I do my 36 squared, that gives me 1,296 plus my 27 squared gives me 729. And then my 45 squared gives me 2,025. So I need to see, does this side equal the 2,025? If it does, then yes, this is a right triangle because it meets the qualifications for the Pythagorean theorem. If it doesn't, then this would not be a right triangle. Even though it looks like it, that right angle that we would consider right angle could be like an 89 or an 88 or a 91 degree angle. So I'm going to check 1,296 plus 729. If it equals 2,025, then it is a right triangle, and it does. So they are equal to each other, which means that yes, this is a right triangle. Okay, so when they give us this, in order for it to be a right triangle, because they're no longer going to put that right angle in there right now, because that's what they're having us check, our sides have to equal each other and be equal to one another. Okay, so let's go ahead and try another one. So sometimes they'll give you a picture, and sometimes they're going to give you just numbers, and they're going to say, tell whether these would create a right triangle. So I know fractions we dislike. So as long as we have fractions that are perfect ending or terminating decimals, we could change each of these into their decimal form. So that's what I'm going to choose to do, is I'm going to choose to write this out as 1.5, and this as 2.5, and this as 3.5. Okay, so here's the thing. We don't have a picture, right? Which means, how do I decide which one's my A and which one's my B? Well, remember, your C is always the longest side. It doesn't matter which A and B, but as long as you can identify the longest side, this has to be our C. So when I go through to do this, I'm going to do 1.5 squared plus 2.5 squared, and hopefully that equals 3.5 squared. Okay, so I'm going to pull my calculator out, and I'm going to simplify each of these. 1.5 squared gives me 2.25. Okay, 2.5 squared gives me 6.25. And then 3.5 squared gives me 12. I did that right. 0.25. Okay, when I add these together, I can actually on this one use some estimation. That is nowhere close to 12 because 2 plus 6 is 8. So this is really 8.5, but I didn't even need to use a calculator. This would be a no. This would not create a right triangle because my sides are not equal to each other. Remember in the last one, we ended up with 2,025 on each side of our equal sign. And here we had 8.5 equals 12.25, and those are not equal. So therefore, that does not meet a right triangle. Okay, so here's another picture one. Okay, once again, checking it out. Visually, it looks pretty close, and some of you might look at it and say visually, I don't see a right angle, but we're gonna go ahead and work through this one because we don't always have the picture. So we're gonna go ahead and do this one as if we didn't have the picture there. So when I go through my right, these are the ones that look like they're the right angle or close to it. I can already tell visually it's not, but we're gonna practice the steps. So 21 squared plus 20 squared equals 28 squared. Like I said, we're not always going to have the picture, so we have to understand the steps. So 21 squared gives me 441, plus 20 squared is 400, equals 28 squared is 784. Okay, so now when I add my A and B together, I get 841. Is that equal to 784? No, it's not. So this would be a no. And I know visually, some of you probably could see that this is not a right angle right here. Like I said, we're using it to practice the concept so that we understand if they were to give us just the numbers 28, 20, and 21, we could still go through and figure out if it's a right triangle without the picture. Okay, so what I want you guys to do is on this one, no picture given, I want you to go through and identify whether or not this creates a right triangle. So remember, your C side is your longest side, that's your hypotenuse. So go ahead and pause your video, work your way through this one, and then check back to see what your final answer is. Okay, so in this situation, we did end up with a right triangle. We ended up with 1.5625 as both of our sides. So this would be a true statement of yes, this creates a right triangle. So that's it for the rest of this lesson. So the key thing on this, if you're given a set of numbers or a picture with all three sides and they're asking if it would be a right triangle, it must fill into our Pythagorean theorem and both sides must be equal to each other.